Hi class. So we'll continue this set of animation, but we're going to take a shift now. Previously, we were doing this frame-based, where you have these pre-rendered frames, and you flip them to get your animation. But now we're going to move to more dynamic, geometry-based animation. So what we do is, we go back to how we've been learning drawing throughout the course, where we specify our drawings, or specify our scene in terms of geometry. Using geometry, like drawing commands. And then once we have that, we can use our transforms to change their shape or position or size, and we do that dynamically. So we use dynamic transforms to achieve animation. And I'm going to underline dynamic transforms here, because we already know about transforming our objects, but if we make that transform change over time, a scale or a size or a position, you're going to get animation. And you can do this with any characteristic you might think about. For example, location, size, you can do rotation, and so on and so forth. So any property you think about, you can change them over time, you get animation. Now, the first approach I'm going to talk about here is actually quite simple. I'll actually be introducing two different approaches, and in practice you're going to use both, okay? They're not one or the other. But the simple approach is that you just provide a relative change each frame. So you're drawing your scene or your object, and then each frame you say, well, I'm going to move you a little bit more to the right. And if you do that smoothly and you do a change every frame, you're going to get animation. For example, here we move to the right 10 units, and your object will animate across the scene. You can imagine, maybe perhaps rotating 10 degrees clockwise or something like this, right? So you can imagine any number of changes that you make each frame. So you draw your scene, each frame you make a small change, you draw it again, you get animation. That's the first approach. Let's give a demo. Right, so here's the code. It's a very simple program. We have some globals here. Speed is how fast it moves, and rotate speed is how fast it turns. We have our X and a Y, which is the position of the object, the angle, and this is the scale factor. 1 means no change, and if it's bigger, it's 2 means double the size. So we're on a canvas of -1 to 1, so standard NDC style coordinate system. Now what we do is we calculate the difference between the mouse coordinate and the current object position. So this mess here, this is just converting the mouse from the viewport coordinates to the -1 to +1, and then to Y the same thing. We've seen this before. So this just converts your mouse to your world coordinates, and then you subtract X to find the difference in the X direction, you subtract Y. So you go mouse minus X gives you a vector to the mouse. That's it. So I get this vector to the mouse, I calculate how far away the mouse is by using my distance function, and then I divide X and Y by my distance to normalize that, so it's length 1 in the right direction, and I multiply by my speed. So this is all just standard vector algebra, but basically X and Y move toward the mouse at the speed rate, 0.01 there. And then what we do is, that's the first animation. If it's on the top part of the screen, if Y is above 0, then it's going to grow bigger. If it's below 0, it's going to shrink. And then we can, in each turn, no matter where we are, we rotate a little bit. So we translate, rotate, scale, and draw shape. So this is the standard form of animation where each scene, we just make a small change. X changes a bit, Y changes a bit, my size changes a bit, my angle changes a bit, and you get animation. The shape we're drawing is just a quad. It's nothing fancy, and we set up our transformation. So let's see what this looks like. Come on, there we go. See, it's following my mouse. It's moving towards my mouse a little bit, and depending where it is, it grows or shrinks, and it's rotating. So all that we're doing each frame is we change the X position, change the Y position toward our goal, we change the size, we change the rotation, and we get this nice animation effect. Okay. So that's a simple way to do animation. And that's probably what you'll be doing for certain parts of your later assignments. The pros of this approach are many. Oops. The pros are you get full control. Okay, it's full control and flexible. So if you want to rotate a little bit to the right, you just say rotate a little bit to the right. You just specify exactly what you want, and you got it. It's also really easy to implement. As you saw in my code here, it's easy to understand, easy to implement. You just make a change. The downsides, the cons of this, is that it's hard to manage global or bigger goals. Hard to manage global, or I'll say bigger goals. And what I mean by this is, if you want your object to go here and then spin and come over here and turn, or you want the object to, perhaps do this for a while, then do that, it becomes tricky to manage. You're going to have to create a complicated state machine to do that. So for example, move here, then slow down, then move there. Right? You want to do that kind of thing. It becomes tricky, and you have this overlay of logic which complicates your scene. So this leads us to the approach number 2. I just realized I called this one approach number 2. Let's call it approach number 1, because that was a mistake. This leads us to approach number 2. And that's keyframes. So keyframes are just basically what happens is all these problems I mentioned in the first one, we got to come up with a state machine, we got to manage it, we got to do all that stuff. Well, people have figured that out. It's been solved, and we solve those problems using this approach called keyframes. So that's like the natural progression. And so the way keyframes work is, instead of thinking about our micro change, what are we doing right now, we provide a list of goals. We provide a list of goal configurations. And then we move between those configurations. Okay. These goal configurations are called, and you guessed it, keyframes. Okay, so this is a keyframe. The keyframes themselves, the keyframe are those goal positions. So if I have an animation that I'm laying out on my screen, you can imagine I start over here in this configuration, I'll call that 1. I want to end up over here in this configuration, I'll call that 2. And then after that's finished, I'll come down here and stretch it out, and I'm in that configuration, that's called 3. And so the goal is we have these 3 keyframes, these 3 configurations that you specify. Okay. Once we do that, you then calculate the configurations in between them smoothly. So we calculate the configurations between these keyframes. And you can visualize, I'm going to draw it out, but you could visualize or imagine now that this is going to move in a straight line here and rotate as it goes. And then once it gets there, then it'll move over towards 3 and rotate and change size as it goes. So these are our keyframes. And then we have this in-between section that we're trying to calculate, these configurations in between. And these have a really interesting names. They're called the in-betweens. So we calculate what's in between the keyframes. We calculate the in-betweens to go there and there. That's where our in-betweens are. So this process where we go, let's try that again. This process, go between keyframes and calculate the in-between positions, which we call the in-betweens. This process is called tweening. Now I know these are really silly names. We have in-betweens, we have tweening, but this is actually standard language. So you'll even come across it in like certain tools like Photoshop and Premiere and all these professional tools if you do animation. So tweening and in-betweens and keyframes are the standard language. So the way that it works is, as we draw, we have our keyframes, that's good. To calculate the in-betweens, to do a tweening, each frame we just recalculate it. So each frame, we keep track of where we were basically. We keep track of where we are in the tweening. Okay, we keep track of that. For example, you could imagine last frame I was right here. Let's say this is 35%, which doesn't look visually accurate, but that's okay. We keep track if we were in the tweening, for example, 35%, and then just calculate the next spot next time. So we keep track of where we are, and each frame we draw, we move our position along until we get to our keyframe. We reconfigure the next keyframe, we move it along. So this is a process that's called the process that's called tweening. So this is a good place to stop. I'll come back and we'll learn about how to actually implement the basic ways of actually implementing tweening.